Ever wondered how massive tech companies fend off hackers while processing millions of transactions every second? I'm Rasmus, and I secure systems for a living. And trust me, it's not as smooth as it looks. Today, we're going to talk about what really goes into keeping these systems secure. They're built on layers of complexity, risk, and trade-offs. Every decision matters. Keeping them secure, that's the hard part. Sounds complicated, right? Like me trying to understand calculus in college. But this will make it make sense. This is Mark. He's a junior developer, and this is his first day at his new job at Skyflow Analytics. Skyflow Analytics is a weather forecasting company that utilizes AI for personalized weather forecasting. His first task involves setting up a login page where customers can log into their accounts. Mark realizes he'll need a front end for the login page, a backend to handle authentication, and a database to store user credentials. When a user attempts to log in, the front end sends the login credentials to the backend. The backend then queries the database to verify if the user exists and the password matches. Once validated, the backend responds to the front end, letting the user know if they're successfully logged in. Mark jumps right into coding. He crafts the login UI and builds out the backend components that handle the user authentication. After tying everything together, he does a quick test run and just makes sure things are running smoothly. Developing the login UI, Mark uses the technologies he knows best. Next.js as the React framework, TypeScript for type safety, and Tailwind CSS for efficient styling. For managing users, Mark chose Postgres as the database for its reliability, scalability, and strong support for relational data. For the backend, Mark chose Python, utilizing Flask to build API endpoints that handle user authentication, verifying credentials against the Postgres database. Finally, after countless hours of coding, debugging, and problem solving, Mark finally deploys the login page. His first real success as a junior developer. With the job done, he kicks back and chills. With the login page published, users start logging in like clockwork. Maybe this dev thing isn't so hard after all. Mark's login page got hacked. But what happened? A malicious user injects SQL into the login form. The backend includes it directly in a query without validation, and the database executes it, returning unauthorized data. So how could this have been prevented? Mark could have implemented parameterized queries to block the SQL injection, and in this case it would have worked. But then came the cross-site scripting attack. One control mitigated one risk, the next exploited another. Because when you're defending systems, you don't get to choose the attack. You have to be ready for all of them. That's why real security isn't about reacting to vulnerabilities one by one. It's about building a complete security posture proactively. And that posture doesn't come from isolated fixes. It's built by integrating security into every phase of software development. Integrating security in software development isn't about tools or buzzwords. It starts with understanding how your software is built, your process, your flow, your lifecycle. Once that's defined, you embed security controls into that process at the right stages with the right focus. The result? Software that doesn't just function, it reflects a deliberate security posture. So, how do you build that kind of security? It starts with the fundamentals, the same ones I was once taught. Let me introduce you to the development triangle, the three pillars every software system stands on. System design, implementation, and testing. System design lays the blueprint. It defines how components interact, what the system must achieve, and how it should behave. And the goal is simple: build something stable, secure, and scalable. To get there, we define clear requirements, functional, non-functional, and constraints. We make key decisions about system structure, data flow, and technologies. And we document everything from architecture diagrams to integration points. Good design sets the direction, so we build the right thing the right way. With the design locked in, it's time to build. Welcome to the implementation phase, where code brings it all to life. We stick to clean code principles and industry standards and base every implementation on the requirements outlined in the system design phase. Let's look at an example of insecure implementation. This code takes user input and injects it directly into an SQL query, making it highly vulnerable to SQL injection. An attacker could manipulate the input to access or alter sensitive data. The fix lies in this code. Here we use parameterized queries, separating user input from the SQL code, eliminating the risk of SQL injection. And before the query even runs, we validate the input to ensure the user ID is a valid integer. Once code is written, it's time to test. The testing phase ensures the system works as intended under real conditions. Here we verify that the system meets the requirements defined during the design phase. To do that, we turn each requirement into test cases, designed using structured testing rules. Each test case defines what to test, how to test it, and the expected results. To scale testing and catch issues early, we automate test cases wherever possible. This reduces manual effort, lowers the risk of human error, and allows frequent testing after each code change. Automated tests run continuously, either in a CI/CD pipeline or as scheduled jobs, verifying system functionality. They deliver fast, reliable feedback and helps team catch issues long before they reach production. Let's connect the dots. System design typically comes first, providing specifications that guide implementation. Implementation turns specifications into software. Testing verifies it works as intended. Great software isn't built in one direction. Implementation feeds back into design, refining specs and exposing real-world constraints. Test results guide developers, pinpointing bugs and revealing what needs to be fixed. Testing uncovers more than bugs. It reveals flaws in the design, helping refine the specification and strengthen future iterations. To build systems that are not just functional but also secure, we need to get every part right. That means embedding specific security activities within each area, tailored to the risks, technologies, and decisions made at that stage. From design choices to implementation details and testing strategies, security has to be deliberate, not reactive. In the next episodes, we'll break it all down, step by step, and show how to apply these practices in the real world. Thank you for watching.